Good morning, ladies. It's Mr. O'Sullivan. Today we're going to be learning about how to factor using GCF leftover polynomial. Today's learning target is I can apply the GCF leftover polynomial method to rewrite a polynomial expression. So way back when last year we learned about prime factorization and how we could use it to factor a polynomial. So the whole goal of factoring by using GCF is to actually break apart each term by using prime factorization. If you look over here, we have a visual of prime factorization where we break apart 90 by doing 9 times 10, and then we break apart 9 and 10 even further into just prime numbers, simply 3 times 3 times 2 times 5. So for the first two examples, we want to use prime factorization to rewrite each of the following. So for our first example, we have the number 24. The first thing we have to ask ourselves is, what two numbers multiply to 24? Do you happen to know one? Because I know a few. And what I'm going to do is, I'm going to do 2 times 12. And what's nice is you could also do 3 times 8 or 4 times 6, and you'll still get the exact same answer. I have to ask myself, can I break apart a 2 anymore? And the answer is no. I can only break it apart to 1 and 2. When you can only break it apart into 1 in itself, that means it's a prime number, so you circle it. I'm now going to break apart my 12 even further. I'm going to do 2 times 6. And again, I can't break apart my 2 anymore. And then I'm going to break apart my 6 into 2 and 3, and I can't break apart no more. So I just did the prime factorization of 24. And I can say my prime factorization is 2 times 2 times 2 times 3. That's your prime factorization. And the whole goal is to only have prime numbers left. Now let's go on to our next example. In this example, we made it a little more challenging by throwing a variable on it. So I want to find the prime factorization of 25x squared. Well, I have to ask you what multiplies to 25. Do you know? Good. The two numbers that multiply to 25 are 5 and 5. We're going to hold off on this x squared until we rewrite. So I have 5 and 5. Here's the issue. I can't break apart 5 and 5 anymore, so I circle them because they're prime numbers. So when writing the prime factorization, I have 5 times 5. Ooh, I'm going to erase something real fast. You're going to see why in a minute. I have 5 times 5. But I also have to bring apart this x squared down here. So now I have to ask you, how many x's do you have? I have 2. So I'm going to write times x times x. And that's your prime factorization. So to factor is to rewrite an algebraic expression as an equivalent product, which basically means that we're multiplying our terms together. And the first type of factoring you should always look for is the GCF. So for GCF, you're simply just calling it the greatest common factor. And in a way, you're basically trying to figure out what's the highest number that can go into each term or variable, but we're just going to focus on prime factorization. If you notice the trick, you can use the trick. So let's do some examples. The first step of any GCF leftover is to basically find the prime factorization of each terms. So if I look at my first example where I want to find the factors of 6x squared plus 10x, I break apart my 6x squared and I break apart my 10x. So I ask myself, what multiplies to 6? It's 2 and 3. I can't break it apart anymore, so I'm going to circle my 2 and my 3. I circle my 2 and my 3, and I rewrite this down here as 6x squared equals 2 times 3 times however many x's I have. And I have 2 x's. So times x times x. Now I'm going to find the prime factorization of 10x. To find the prime factorization of 10x, I ask myself, what multiplies to 10? 2 times 5. What's nice about this one is that they are both prime, so I'm going to circle them. So I can rewrite 10x as 2 times 5 times x. So now that we have our terms and their factorizations stacked on top of each other, I now want to ask you, what do you notice is in common to both factorizations? So what's in common between this expression and this expression? Take a second. I notice that they both have a 2. I also notice that they both have an x. So I can say that my GCF is 2 times x, or 2x. Because you just do 2 times x, which is 2x. You don't do 2 times 2 times x, that would mess it up. You just do the 2 times x. So now that we have our GCF of 2x and our leftovers, we now write our factorization as GCF times our leftover polynomials. So we write our GCF first, and we said our GCF before was 2x, so I'm going to write 2x, and now I look at my leftovers. In my first expression, I just have a 3x, and in my second expression, I just have a 5. So I do 3x plus 5, and that's your final answer. Now what we're going to do is we're going to make it a little more challenging. We're going to factor 3 terms. So what we want to do is we want to find the GCF of this trinomial and rewrite it using GCF leftover polynomial. So the first thing we do is we find the prime factorizations of each term. What I would recommend is that you try to do this part by yourself. So I'm going to find the prime factorization of 6x cubed, 8x squared, and 2x. But you have to remember that this is a negative 8. It'll play a role when we do our GCF leftovers. So the first thing I do is I break apart my 6 into 2 times 3. I can't go anymore, so I'm going to circle my primes. So my primes are 2 and 3. So I know 6x cubed equals 2 times 3 times x times x times x, because I have 3 x's. Now I want to find the prime factorization of 8x squared. So I have 2 times 4, circle my 2. And then I have 2 times 2. And they're all prime. So I now have my minus 8x squared. Oh, you don't have to write minus 8x squared, sorry. You just have to write 8x squared. Just remember that it's minus at the end. So I'm going to write my 8x squared as 2 times 2 times 2. And I'm going to write 2 x's this time because I'm squaring them. Now I just have a 2x, and I ask myself, can I break apart a 2? No, it's just 2 and 1. So I'm going to circle, circle. You don't have to do that part. Just know that it's 2 times 1. And now I'm going to write 2x as 2 times 1 times x. Now we need to find our GCF, and we do that by circling what's in common. So now that we want to look at our greatest common factor and see what they have in common, I'm going to use my black marker, and we're going to look at what they have in common. Well, what do you notice that they have in common? They all have a 2. And they all have at least 1x. So my GCF is simply 2x. So I rewrite it as GCF leftover, so 2x, and my leftovers are 3x squared. So I have 2x times 3x squared. My leftovers and my minus 8x squared. The reason why it's minus 8x squared is because, look, it's a minus in the beginning, so I got to keep it a minus. My leftovers are 2 times x, which is just 4x. So minus 4x. And then my final piece is positive because of that 2x. So it's just going to be plus 1 because that's my only leftover. And that's your final answer. 2x times 3x squared minus 4x plus 1. If you have any questions, please don't hesitate to email myself or Miss Daniel. Miss Daniel is holding extra help today from 9:55 to 10:50. So again, if you have any questions, please stop by her Zoom or email me or come by during extra help today from 1:35 to 2:30. Again, watch the Ed puzzle, answer the questions, and do your delta math. Have a great day, ladies.